Khalid and I have known each other for a little over 10 years now. And over about a couple years ago, I started trying to figure out what I wanted to do next with the next, I don't know, 20 years of my life focused on space. And one thing that kind of stood out to me was the fact that we kept talking about making humanity a multi-planet species, and we always talked about Moon, Mars, and beyond. And yet we were somehow missing Venus in the discussion. And I wasn't exactly sure why. Well, actually, I knew exactly why, because the surface of Venus is so completely inhospitable. However, it turns out, as some of you in this audience probably already knows, that the Venusian atmosphere is a lot more hospitable potentially to human life. And so I started thinking that it might be a worthwhile effort to put together a group that would insert Venus as a discussion topic into this global discussion about making humanity a multi-planet species. And since I'm not a scientist or an engineer, I knew I needed someone who I trusted and was of a like mind and similar background, who had more of an engineering and science background, to collaborate with me on this. And like I said, Khalid and I have known each other for over 10 years. He does, when you look at his bio, you'll be impressed of his breadth of experience in engineering, science, entrepreneurship, investment, government, corporate, startups. He's done everything. So we started talking, and it turns out that he was also interested in promoting Venus as a potential destination for humanity in the future. So for the last year or two, we've been working on this project called Humans to Venus. Cole, could you move to the next slide? And by the way, Khalid and I are going to kind of do this a little bit interactively. Maybe I'll talk a little bit and then Khalid will jump in whenever he wants. But essentially, everything that we're trying to do with our group is aim toward this long-term vision of setting up a permanent human presence in the Venusian atmosphere over the next 30 years. And to date, right now, we've got about 20 or so part-time volunteer members in the US and Europe that are working in various parts of what we're working on. But this is another opportunity, I guess, to present to all of you that if you are interested in looking at Venus as a potential destination, that you should please feel free to reach out to me or Khalid, and we'll find a way of getting you involved in what we're doing. We're just getting started with our fundraising efforts, and hope to have more of a full-time core staff in the coming months. By the way, Khalid, I'll just pause every now and then if you want to jump in too.
Yeah, I'll jump in right here. And thanks to all for your time today, and for the Mars University team, and specifically Cole, to invite us here today to talk to you about some of the exciting stuff that we're up to. This is one of the first times we're actually coming out to the public to talk about this, and that's why it's a little bit of a high-level overview. As you hear more and more about us, we'll be unveiling more and more about our plans. Of course, the purpose of what we're doing is to bring Venus back to its rightful place as effectively the most visible planet in our night sky, and henceforth should be the one that draws most of our attention. It has indeed drew my attention since I was a young boy with my telescope, looking at all the planets and looking at the phases of Venus and looking how beautiful it was. Of course, it's a hostile place to be. That for an engineer means challenge, doesn't mean impossible. And you've heard from Dr. Sarah Seeger and Jane Greaves about the exciting work that's been done that has effectively thrust Venus right at the forefront of attention within more the broader community. The scientific community has always been interested in Venus. Many of you know that we've had 48 missions and going into that planet. Is one of the first places we went to look and check out. But now with modern technology, and of course the angle that we bring to the table more than anything is the commercial thrust towards Venus. not just the government one, and the ability to be able to campaign and launch missions to Venus completely privately funded, as you've heard about the news with rocket plane going out there possibly next year. So very, very exciting time, and look forward to having this conversation with you today.
Cole, can you go to the next slide? So actually this slide and the next slide are, for this particular audience, maybe a little bit redundant because you probably already know this, but it's been interesting in discussing this with folks both inside the space industry and outside the space industry. You know, why Venus? We get that question all the time, and there are a number of reasons why Venus would make sense, specifically the Venusian atmosphere, about 50 kilometers or so off the surface. But the number one reason is gravity. At 50 kilometers off the Venusian surface, we believe we'd experience 1G of gravity. And that's one thing that when we look at setting up permanent off-world settlements and getting humanity off planet on a long-term multi-generational basis, that's something that we just can't overcome on the moon or on Mars. And the medical community still today has no idea how that lower gravity will impact Homo sapiens going forward generation after generation. So if even just for the fact that there's 1G of gravity in the Venusian atmosphere, that seems to be reason enough to at least entertain Venus as a potential, or at least explore the possibility of Venus as a destination for humanity, or a permanent off-world settlement. And by the way, I said this may be a little redundant, also this slide and the next slide, because I know Mars University is also, you can stay on this slide, yeah. Mars University has had two great talks recently, one by Sarah Seeger and one by Jeffrey Landis, where they went into a lot of detail on the science behind this and also on some of the engineering behind this.
So I'll jump in over here as I'm seeing some of the questions that are coming up. Some folks probably may have not heard those talks. So humans are quite well adapted to the Earth environment, which is a combination of gravity, pressure, temperature, atmosphere composition, radiation protection from the Van Allen belts, and so forth. And of course, the unusual presence of oxygen, and of course, we're a water planet on top of everything. The test of humans as a multiplanetary species is on which types of conditions can we actually, let's say, compromise on and still not only survive but also thrive. Obviously, radiation is a big challenge, and it turns out gravity is a very big challenge. Just looking at astronauts who are spending extended time on the space station, you see the brutal impact that gravity has, the microgravity environment has on the human body as the bones start to demineralize and muscles start to atrophy. So then as we hunt for places, let's say, that are other cocoons that can host human life, this happens to be a Goldilocks zone. And to answer the question that was asked, you know, if Venus is so hot, what's the advantage of temperature? We're talking here about being suspended about 50-some kilometers in the atmosphere of Venus, not on the surface of Venus. Right there's that spot where you're almost 1G, you're about 20 degrees Celsius. There's radiation protection and so on. So that confers advantage over Mars, because it's still unknown whether on the moon or Mars, whether that low gravity environment is sustainable for humans. And of course, then you would have to develop technologies to increase gravity somehow, where in Venus, it's a given. Of course, you have to contend with the fact that the clouds are sulfuric acid, and also the surface can melt lead, is 700 Kelvin over there. So then technology has to be of the type where we can sustain presence in the clouds.
Yeah, and I'm glad you brought up the sulfuric acid clouds. That's one big thing. And then the other big thing is that the atmosphere is primarily carbon dioxide.
That's right.
So those are the two big detractions. And then also the atmosphere itself, very high velocity winds, 200 to 300 mile an hour. Anyway, but that, we could spend an entire hour just talking about the science behind all this. And in fact, I'd encourage you to watch the Mars University talks by Sarah Seeger and Jeffrey Landis. They do a great job on this stuff. Cole, can you go to the next slide? And this was also part of Jeffrey Landis's talk. Someone in the chat put what the concept might look like. Well, NASA already developed a potential concept called HAVOC. And this is kind of the vision for it. And one of the other nice things about the atmosphere there is we wouldn't need lifting gases there because of the way the atmosphere composition is at that level. So those floating structures that you see in there inside could be normal Earth atmosphere, right? Primarily nitrogen and oxygen. So in Venus's atmosphere, that would actually be a lifting gas. So you could actually live inside.
And if you sprung a leak, it's not going to deflate so fast because the pressures are equal on both sides of that membrane.
Yes, and AC is correct in the chat that Venus does not have a magnetic field to provide radiation protection, but the rest of the atmosphere that's left above the 50-kilometer line provides enough radiation protection, even though there's no magnetic field and Venus is closer to the sun than Earth.
That's right.
It's
definitely superior to Mars in that regard.
Yeah, and again, I think the main point of this slide is that this isn't new. We're not breaking new ground as far as humans to Venus coming up with new stuff. And again, Jeffrey Landis did a great job during the Mars University talk talking about the HAVOC program. Cole, can you go to the next slide? Because the next two slides are the ones that we really want to talk about. So this is the very, very high level what we're working on with humans to Venus. As Khalid said, this is the first time we've actually talked publicly about all this. You can kind of consider this a little bit of kind of a soft launch for us. We're looking at potentially making much bigger, more detailed public announcements at the end of October. So you're getting a little bit of a sneak preview of what's coming in the next couple of months. Long term, we've got a 30-year plan for how to do this, but we figure the first 10 years are going to be the most critical. So we've sketched out a slate of 4 missions that we think is aggressive but doable in the next 10 years. And the ultimate goal at the end of these 10 years would be to do a crewed flyby, basically send humans on a flyby of Venus. It's a 12-month mission. In order to do that, we would have to first obviously do an uncrewed flyby. So I'm kind of working from the bottom of the slide up, kind of working our way backward. And before that, we'd want to do at least 2 robotic missions. One is a tech demo, very similar to the HAVOC program, basically to test out some of these technologies of dropping something into an atmosphere, having it inflate, and then cruise around at 50 kilometers while collecting data. So part of it is the purpose would be to collect the data, but it's mostly to test the demo, to demo the technology of actually dropping something into the atmosphere and inflating. But before that, we're looking at doing a mission that we've tentatively called SolarMax 2025, and that is to send a probe to Venus in time for the next solar maximum, which is in 2025. The main reason for this, well, actually, we'll talk through this, is that crewed flyby. If you look at the at the timeline, that crewed flyby is going to happen right about the next solar maximum. So we're going to be sending humans into harm's way when it comes to radiation and the solar cycle. And so we want to try grabbing as much data as we can during this solar maximum before 10 years from now we send humans around Venus. Let me pause there for Khalid.
There's one take home from this chart. Again, Venus is no stranger to us sending missions to it. But if you look at the frequency of these missions, what we plan to bring to the table is an increase in cadence of these types of missions, rather than scientists waiting for their payload for a decade or two before it sees the light of day. And I'm one who've worked a whole decade at NASA, built spacecraft and flew them, and I've had a spacecraft that have built, thermovac tested, ready to go, haven't flown. So partly because of just how the process is. So one of our contributions is to affect this type of change in the infrastructure required to have successive and successful launches to missions of that scale. Of course, in a sense, the way to think about it is how frequent low Earth orbit missions are now. I think the same when it comes to going to Venus.
Yeah, and I think to kind of underscore Khalid's point, if you think about our long-term vision is 30 years, right? Over that time, we'll probably need to do 50 or 60 missions, but it's not a straight line ramp up in those missions. So in the first 10 years, maybe we do 4 missions, but in the next 10 years after that, it'll be 10, 15 missions, and then in the last 10 years will be a lot more. So it'll be an increasing cadence, as Khalid pointed out. Cole, can you go to the next slide, please? And I saw your note about the time running out. So this is just a little bit more specific on the Solar Max mission. And actually, I just realized that we already talked through all this stuff, so we're not really saying anything new with this slide, other than actually, Cole, you may as well go to the last slide. Other than to reemphasize that we're building up a team to put all this kind of stuff together. We're going out and getting funding to get to the next steps. So if any of you are interested in this kind of work, if interested in Venus or off-world settlement or private missions or anything like this, we encourage you to reach out to Khalid or myself. You've got our email addresses right there. And yeah, and we can go from there. Khalid, I'll let you close everything out.
Indeed, and thanks again, everyone, for your time, and looking forward to your questions that we'll answer shortly. Guillermo and I are very excited to share this with you today. This is an open invitation for you to jump into this process and see where you might be someone who's interested in some of the missions we've got. The idea here is that it's a combination of science and technology missions in order to make these types of missions quite commonplace, whether it's radiation protection technologies, you name it. So thanks again, and looking forward to talking to you.
Awesome. Thanks so much, Guillermo and Khalid. I can have a few questions or for the next presentation.
There's at least one I see in the chat.
I have a quick question. The process of getting there, are there any flybys required to get there, or can we just fly there, come back? It's not Mars difficulty level? The Rocket Lab seems to be going there pretty soon anyway, so.
Khalid, I'll let you take that one.
Yeah,
sure. It's there are several ways to get there. Although Venus, because of its orbit and retrograde spin, presents its own challenges when it comes to orbit insertion and so forth, depending on what you're trying to do on that planet. We're not looking at any as you saw in the long term. We're looking at return. Right now, there'll be effectively robotic missions that are one-way trips to Venus, just like the one that Rocket Lab has planned. This is because, from a commercial perspective, and we want to have a launch relatively soon, it has to be both feasible and also affordable. So then from that a sample return is a much bigger, or a return mission is a much bigger endeavor, and we have that. It's part of our long-term plans. We plan it now, but in the short term, we will be going out there to right when the sun hits its max this cycle, and this is a very interesting maximum for the sun, as you see it in the news. it'll be very good to see the sun up close, get effectively a front row seat. I think Venus I think Mercury is more in the splash zone, and Venus is more in the better spot for us to see what the sun is up to and its impact on the Venusian atmosphere. So that presents an opportunity to collect very good and useful and one-of-a-kind data for that particular moment of time. And then from there, you see successive missions culminating into return missions, including human flyby and return.